A phase diagram indicates the temperature and pressure conditions under which a substance is a solid, a liquid, or a gas. The lines that separate the phases are called phase boundaries. At any point along a phase boundary, the phases exist in equilibrium with one another. For example, in the phase diagram of water, at 1 atmosphere of pressure and 100 degrees Celsius, liquid water and water vapor exist in equilibrium. This point is known as the normal boiling point of water. Likewise, the temperature at which solid and liquid water are in equilibrium at 1 atmosphere of pressure is known as the normal melting point. The point at which all three phase boundaries come together is known as the triple point. This corresponds to the temperature and pressure combination at which all three phases of a substance exist simultaneously in equilibrium. When a sample of solid water or ice at 1 atmosphere of pressure is heated, it will melt when the normal melting point, 0 degrees Celsius, is reached. At this point, water crosses the solid-liquid phase boundary. If the sample is heated further, the liquid water's temperature will increase until it reaches the normal boiling point, 100 degrees Celsius. It will then vaporize, crossing the liquid-gas phase boundary. Once the liquid is all vaporized, the temperature of the water vapor will increase as more heat is added. If a sample of solid water is heated at a pressure below the triple point, it will sublime rather than melt as the temperature increases, because the only phase boundary it will cross is that between the solid and vapor phases. We can also track the changes in a sample of water as we vary pressure. If the pressure is increased on a sample of water vapor at 110 degrees Celsius, it will condense as it crosses the gas-liquid phase boundary. Note that a sample of solid water or ice at a temperature slightly below the normal melting point will cross the solid-liquid phase boundary and melt as pressure is increased. This is one of water's unusual properties. The critical temperature is the temperature above which a gas cannot be liquefied regardless of the amount of pressure applied. The critical pressure is the pressure necessary to liquefy a gas at the critical temperature. The critical point is defined by the critical temperature and the critical pressure. Note that there is no phase boundary beyond the critical point. A substance in this region is known as a supercritical fluid and has properties associated with both gases and liquids.